Yeah.
My mind doesn't have the capacity to expand this sense of distance and size to that grasp. Is this because of just the way we evolved? We evolved here on Earth to deal with the space that's in front of us, and now over the course of industrial civilization and education, we're now grasping these concepts that are so alien to the reality, the tangible reality that we exist in every day?
I'm sure that's right. Even very simple things, like you go back to the Greeks, so Aristotle and the great, very clever people, but they thought the Earth was at the centre of the universe. Why? Because it feels like it's at the centre of the universe. It feels like we're not moving. And the Greeks quite naturally said, well, because we're at the centre of the universe. They also said everything falls towards the Earth, so therefore the Earth must be at the centre. It's natural.
Right.
And actually it's quite a deep thought to understand why it doesn't feel that we're moving. You have to go all the way to Einstein, really, for someone to take that very seriously. And he said, well, there's a great little explanation in Stephen Hawking's Brief History of Time about this, that the idea that you can't tell whether you're moving or not demolishes the notion of absolute space. So if we think about space, if I said space to you or most people, I suppose, you'd think the way that Newton did, of a big box within which things happen. And that's a natural picture of space and the universe, isn't it? It's a thing in which all the planets and galaxies are placed. But in the Brief History of Time, Hawking says, well, imagine bouncing a ball. So we bounce a ball on the table now, a tennis ball. So I drop it and I catch it again. So let's say I drop it and it takes a second to bounce up. So in that second, the Earth has moved about 18 miles or so in space around the sun. So you could ask the question, did that ball return to the same place in space or not? And the answer is, you can't answer it. It does from our perspective, but from the perspective of someone watching the Earth go all the way around the sun, when I caught it again, it had moved 18 miles. And then from some other perspective, it would have done something else. So the point is, you can't say this is a point in space. It came back to the same place, because that just depends on your perspective. It depends on whether you're watching the Earth go around the sun or whatever it is. So Einstein said that means there's no such thing as absolute space, which kind of follows if you think about it. But that's it's a cool but difficult thought process. And Einstein elevated that to a principle and said, if you're not accelerating, you're just moving at a constant speed in a plane, or now. I mean, that's essentially what we're doing now. We're moving around the sun at effectively constant speed. Then you can't tell. We could look at the decay of a radioactive nucleus or some electricity and magnetism, or bounce a ball, have a pendulum, whatever it is. And there's no experiment you can do to tell you whether you're moving or not. Therefore, that concept has no meaning because you can't measure it. And that's led Einstein to relativity. That's the basis of general relativity, which is our best theory of the universe.